Yeah, so the first thing I just want to do is cover any problems, because problem areas. Otherwise, every time you come across a question like that, we just get stuck, don't we? So if we look at this, so number 12, f of x equals 2 cos 2x over e to the 2 minus x. Curve has a maximum turning point at A and a minimum turning point at B as shown in the diagram. Show that the, right, okay, so if I think about this, my u is going to be 2 cos 2x, and u dash is going to be 2 times by, differential of cos 2x is going to become minus 2 sine 2x. So we get minus 4 sine 2x. And so if we look at v, if v equals e to the 2 minus x, v dash, the differential of the top is minus 1. So we get minus e to the 2 minus x. Okay, is everyone happy with that? So that's my first step. Then I can differentiate this. F dash of x is going to equal vu dash, so e to the 2 minus x times by minus 4 sine 2x minus 2 cos 2x times by minus e to the 2 minus x all over e to the 2 minus x all squared. Don't really need to worry about the denominator, because if I'm looking at a turning point or maximum and minimum points, my numerator is the only thing that's going to be equal to 0. So I don't need to spend time wasting time sorting out the denominator. Now, if I just sort the numerator out, if I write that as slightly better, just so that I can get, if I factorize e to the minus e to the 2 minus x out, I get 4 sine 2x. This minus and a minus make a plus. And so I'm going to have a minus 2 cos 2x in my numerator, all over e to the 2 minus x squared. Now, let's have a think about this. So if I now want to work out my turning points, I'm going to make my numerator equal to 0. So either I get this bracket is equal to 0, or the second bracket is equal to 0. So if I write minus e to the 2 minus x equals 0, that has no solutions. And then we've got 4 sine 2x minus 2 cos 2x equals 0. And that, I think, is taking me to the right answer. So 4 sine 2x equals 2 cos 2x. If I divide both sides by cos 2x, if I think I need to get to tan, then I need to divide both sides by cos, because I want sine over cos. And if it's tan 2x, I need to have sine 2x over cos 2x. So I'm going to get 4 tan 2x equals 2. So tan 2x equals 2 over 4, which is a half. Are you happy with that? Does that make sense? Right, were there any problems with part A? Did you have any problems with part A? Please let me know. Now, part B is saying find the range. Range are allowable y values. So looking at this diagram, I can see that the lowest y value I'm going to have is the y coordinate for B. And then my range is going to be y values of that or higher. So I now need to work out my y value for B. But before I can do that, I have to solve this equation. So tan 2x equals a half. Should have said 2x. Now, even if you couldn't do part A, you should still have had a go at part B, because then I can work out my 2x values that are going to be in this range. Actually, you should say x range is between 0 and pi. 2x, because this is now 2x, range is going to be between, if I multiply both of those by 2, I get 0 and 2 pi. Now, if I think about my class diagram, where is tan positive in A and in T? So this is going to now become 0, 90, 180, 270, and 360. 2x is going to be tan inverse of a half. And what do we get there? Menu 1. This is already in radian mode. I'm going to change it to degrees, and I'm going to change it back into radians later. So inverse tan of 0.5, 26.6 essentially. So this angle here is 2x is equal to 26.6. So this is 26.6 and this is 26.6. So my second angle is going to be 206.6. And so my x values are going to be 13.3 and 103.3. And then if I think about it, obviously this is going to correspond to A and this is going to correspond to B, but we do need to change them into radians. So if I do plus 180 and store that in B, then I can say alpha A divided by 2 equals that times by pi over 180 is how we convert it back into radians. So the first answer we get is 0.232, which I'm going to store in C. And then if I do alpha B, which was 206, divide that by 2, and that gives me back in my range, and then times by pi over 180. And store that in D. So my x values that have stationary points are 0.232 or 1.80. Now, so A is going to have coordinates 0.232 and y, and B is going to have x coordinate 1.80 and some y coordinate. How are we going to work out the y coordinate, please? Can you please tell me how are we going to work out the y coordinate of A and B here? Sub it into which equation? You have to be specific here. Yeah, back into y, that's right. Where it's given us the f of x function. So now I only want the b value. I could work out both of them. In fact, I'm going to do it. So I now just need to ensure that I'm in radian mode because my angles are in radians. So here, if I go into setup and I go into radian mode, I've got my function f of x, 2 cos 2 times by alpha c all over e to the power of 2 minus alpha c. And that gives me a y value of 0.305. And now if I go back and change that to d, that will give me the coordinates of the minimum. And I get minus 1.47. Okay, are you happy with that? Does that make sense so far? Now, can you, now that I've worked out the coordinates of A and B, can you please tell me the range for f of x? Look at what I've worked out and tell me the range for f of x. Range refers to allowable y values. Now, the lowest point is minus 1.47, but the highest point goes on forever here, doesn't it? We can see that there's no upper end. So what we can say is that f of x is greater than or equal to minus 1.47. That's what we should get. I know why it's got that. Oh, right, okay. I know why it's got 6.26. So we've worked out 1/2 of it. Why is the question mark there? Where's the upper end? And how are we going to work out the upper end of this? Any ideas? Right. So x values go between 0. So the lowest x value is 0, but the highest x value is pi. So now we need to substitute pi in to get the highest value in there. Okay, so now we need to work out f of pi to give us a maximum y value. And so let's do that. 2 cos 2 minus pi. And this I will do 2 times pi. And we get f of pi 6.26. So the largest y value is 6.26, but we include 1.47. So what we have to say is f of x is greater than or equal to minus 1.47, because that actually is part of the curve. But we have to go slightly less than pi. It doesn't quite reach 6.26, so it's going to be less than 6.26. So you would lose a mark if the inequalities weren't the right symbol. Okay, and they made a mistake there themselves. That's definitely a mistake. That should have an equal to for minus 1.47. Okay, is everyone happy with that? Any questions at this stage? If I look at the proof for this, again, first thing you're going to do is treat it as 1 over cos x, and then use the quotient rule. When you do use the quotient rule, you come across this y equals dy by dx equals sec x tan x. Okay, so that is the differential of sec x. And that's generally how it's written. If I now look at y equals, we've done sec, we've done cosec, we've done tan. Y equals cot x, dy by dx equals minus cosec squared x. Sine, cos, tan, sec, cosec, cot. Right, this is, so these are the results that you should have shown, again using the quotient rule, and then from there you can do whatever you want. So that's what you'll do. We're just going to move on. Now again, your general formula, if y equals sec f of x dy by dx is going to equal f dash of x sec f of x tan f of x. And if y equals cot, the same thing. We're just going to use the chain rule multiplied by the differential of f of x at the front, and then that remains the same. Right, okay. Anything that has powers, what do you think you need to do? With trig and powers, you need to write it in index form. So that looks like a funny 4. 4 tan cubed x is better written as 4. Only the tan is cubed. So we're going to leave the 4 outside, and we're going to write tan x cubed. Okay, very important that you write that in index form, and then from there, what are you going to do? Please tell me in the chat how you're going to actually start off differentiating this. What technique? Yeah, essentially, yeah, let u equal to tan x, and then it becomes a chain rule. So the technique that you're using is the chain rule. So for this, how are we going to go about doing this? So you should remember, with differentiating a bracket, you're going to multiply the power down, 12, take 1 away from the power of the bracket, that becomes 2. And then what do you have to do? You have to remember to multiply by the differential of this bracket. So differential of tan x is sec squared x. And so we get 12 tan squared x sec squared x. Okay. Does that make sense? Please let me know in the chat if you are happy with that. So firstly, what I notice is that I have got a product of 2 terms over here. So I need to use the product rule for the first part. So I'm going to say u equals x squared, v equals tan a half x. And it's always a good idea to write the angle inside brackets, because we know that is not going to change when we differentiate. The most we're going to do with that bracket is differentiate it. So u dash is going to equal 2x. V dash, when you differentiate tan, we get sec squared. If I've got tan of a half x, differential of a half x is a half sec squared a half x. That's it. We're not doing any more. We're not doing that using the quotient rule. We're not doing any long process. You should now be using the results. Unless the question says show that the differential of tan x is something, you can just use the result. So that's that bit. And so that will be the product rule there. I'm going to come back to that in a second, right? So let's go have a go at that. So dy by dx, vu dash, so tan a half x times 2x. Now, this 2x I'm going to actually write at the front. So 2x tan a half x plus uv dash. So x squared times a half sec squared a half x. So I'm going to write half x squared sec squared a half x. Is everyone happy with the differential of the first bit? The first product? Okay, any questions? Right, okay. If you do have any questions, let me know. And then when you differentiate tan x minus a half, we should be using the result if y equals, so for this term here, if y equals tan f of x, dy by dx equals f dash of x sec squared f of x. So now, when I differentiate x minus a half, I get 1. So therefore it becomes plus 1, but we don't need to write that. So it's essentially sec squared x minus a half. And that's it. There's my answer. I'm not doing anything further than this. Okay, does that make sense? Any questions there? So for cot, when you differentiate cot, you get minus cosec squared x. But if we have y equals cot f of x, dy by dx is going to equal f dash of x minus f dash of x cosec squared f of x. We've got y equals cot 4x. Dy by dx is going to be minus differential of the bracket 4. Cot differentiated becomes cosec minus cosec squared. We've already got the minus here. And that bracket does not change. And there's our answer. It's as simple as that. Does that make sense? All right, okay. Next thing I want you to have a go at is 2D, please. Okay, so 2D is the next thing. Firstly, what we notice is that part D, it has got an index there. So I'm going to write y equals sec 3x to the power of 2. Okay, because it has a power, it's very important I write it in index form like this. Did you do that? Please let me know in the chat. Next thing, when you differentiate this, bring the power down. Take 1 away from the power, so it becomes 1. And then I need to differentiate sec 3x. Now the differential of sec 3x is, if we go back over here, sec f of x is f dash of x, sec f of x tan f of x. So when I differentiate sec 3x, I'm going to differentiate the 3. When I get differentiate the 3x and I get 3. Differentiate sec something, I'm going to get sec of the same thing. Tan of that thing too. And so what we end up getting is 2 sec squared 3x tan, no, not 2, it's going to end up becoming 2 times 3, sorry. So this is going to end up becoming 6. Sec times sec gives me sec squared, and then I've also got tan 3x right at the end. And there's your answer. Does that make sense? So, firstly, you're going to write x, y equals, just so that we can get the hang of this. X cot 3x. Put bracket around any angle. Now, what we should have recognized here is that we have got a product of x and cot 3x. If we've got a product, we should be using the product rule. So u equals x and v equals cot 3x. So u dash is going to equal 1. V dash, when you differentiate cot, you get minus cosec squared. But I've got this 3x here as well. So I need to differentiate that. So we get minus 3 cosec squared, and that bracket won't change. Now we need to use the product rule. So v times by u dash, so dy by dx equals cot 3x times by 1 is simply cot 3x plus x times by minus 3 cosec squared 3x. And so we end up getting cot 3x minus 3x cosec squared 3x. Okay, so just check your working out. Let me know how you've gone according to that.